Good everyone. Thank you for joining this wonderful webinar. My name is Anthony Ezema. I'm the GIS specialist and also an FME expert. I am also the team lead for Evotech Geospatial Consult. All right, let's put our presentation slide on so that we can start up our webinar. I want to thank each and every one of us who are joining from different parts of the world to this webinar. All right, let's share the screen. Okay, thank you for joining us in this another session of Evotech Geospatial Consult webinar. The topic of our webinar is mapping the new world with GeoAI from ground truth to 3D digital twin deployment. With me here are my colleagues, Gamza Mugen, a GIS specialist for Evotech Geospatial Consult. Gamza, can you say hi to the attendees, everyone?
Hi everyone, from Turkey.
Thank you, Gamza. And my colleague, Ugu Paul, an AI specialist for Evotech Geospatial Consult. Hi, Paul. Can you say hi to everyone?
Hi everyone.
Okay, thank you, Paul. My colleague, Olisa Raymond, a software developer for Evotech Geospatial Consult. Raymond, can you say hi to the team?
Yeah, hello, good day. Hi, everyone. I'm Olisa Raymond, a software developer.
Okay, thank you. And with us here, other members of Evotech Geospatial Consult, Samuel and Martin, that are within the background as well, but we, four of us are the major speakers on this webinar. All right, so the topic of the webinar, which I've already stated, we have the subtopic, what you will learn, establishing the ground truth with QGIS for load 1 generation, then using FME to instantly extrude 2D footprints output load 2, then utilizing Evotech load 3 twin 3D synthesizer web application / Blender to generate load 3. We also have the fourth subtopic, which is leveraging session for output deployment. All right, let's move down to the next section. So our topic, as I mentioned, is mapping the new world with GeoAI from ground truth to 3D digital twin deployment. So as for your notice, this webinar is recorded for reference purposes because at the end we'll be posting this webinar on our YouTube channel. Thank you. The next slide. Introduction. What is digital twin? A digital twin is a dynamic virtual representation of a physical asset, process, or environment. Unlike a static 3D, a digital twin is continuously connected to a real-world data stream, enabling it to evolve and reflect real-time conditions, behavior, and changes. An example of digital twin is a digital twin of a city, which might use a real-time sensor data to stimulate how traffic patterns change during a major storm, helping city planners make data-driven decisions. So this is an example of digital twin. We also have other examples where digital twin can be applied, maybe in the health sector, agricultural sector, or maybe even in the entertainment industry in building some equipment. So let's move to the next slide. What is GeoAI? I know a lot of us here have been hearing about GeoAI. So GeoAI is the intersection of artificial intelligence, machine learning, computer vision, deep learning, and geospatial analytics, GIS. It is the technology that automates the extraction of intelligence from massive complex spatial data sets. So GeoAI make use of a lot of data sets. Thank you. Let's move on to the next slide. So for this webinar, if you are within this list of professionals, which I'll be calling out, you are going to benefit very well in this webinar. The first is the GIS and surveying professionals. The second, urban planners and government agencies. The third, civil engineers and BIM professionals. The fourth, university students and researchers, maybe those within the geography or surveying or any related department. Then the fifth, the AI and data science professionals. Then the sixth is drone mapping and remote sensing practitioners. So I'll be handing over to the next slide to my colleague Gamza Mugan. Okay.
Hi, everyone. Thank you, Anthony. Let me share my screen.
Okay.
Just a second, please.
Okay.
I'm sharing now. Did you see Anthony again? As you have just seen, just a second. As you have just seen, our digital twin workflow begins with establishing the ground truth and progresses through increasingly detailed 3D models. Before we move into that practical workflow, I would like to answer an important question. Why has GeoAI become such as essential part of modern GIS? Today's geospatial projects involve enormous volumes of satellite imagery, drone data, leader point clouds, and continuous evolving spatial information. Managing all of these efficiently using traditional GIS workflows alone has become increasingly challenging. That's why GeoAI is transforming the geospatial industry. Here is our route map today. First, we will briefly discuss the limitation of traditional GIS challenges and explore how AI can help overcome these challenges. Next, we will introduce digital twin workflows. Finally, I will demonstrate how to create a simple load one building model in using QGIS, open 3D building data from the Netherlands. Before talking about the digital twin and AI, we should understand the problem. Traditional GIS workflows are powerful, okay, but they face four major challenges. The first is time. Many GIS tasks still require manual interpretation and digitalization. The second challenge is cost. Field surveys, specialist team, and long project durations can significantly increase project budgets. Third is consistency. Also, two analysts looking at the same imagery may comment features differently. And finally, scalability. A single Sentinel, for example, a satellite skin covers approximately 290 kilometers in width. Now, imagine progressing hundreds of scenes manually across an entire country. When AI is integrated into GIS workflows, four important things happen. We gain speed, we gain consistency, we gain the ability to process large data sets, and we gain the ability to continuously update information. Let me give you a real example. While working on building mapping in Abuja, Nigeria, I found areas where OpenStreetMap contained a very limited building information. Using an AI workflow through a MapFlow plugin, I was able to generate a building footprints for that area in approximately 1 or 2 hours. The results was not only building polygons, the systems also estimated building heights and automatically calculate building areas. Before we jump into the tools and into the videos, let's make sure everyone understands what LOT actually means. LOT stands for level of detail. It's CTGML standard from the Open Geospatial Consortium that defines how geometrically and semantically rich our 3D building model is. For LOT 1, the simplest actually 3D representation, think of it as a Lego brick version of a building. For LOT 2, we add, how can I say, the actual roof shape, whatever the building really has. We also add basic surface semantic. LOT 3 for LOT 3, this is where it gets impressive. Windows, door, balcony, something like that. With this video, I will show you how to generate LOT 1 using by QGIS. We used the 3D back data set and Open3D model data sets from the Netherlands. 3D back is an open access data source containing building footprints, height information, and 3D buildings models of different level of detail. Okay, for LOT 1, we selected a study area from the data set and prepared 2 layers. The first layer contains all buildings within the study area, while the second layer contains a single building for which we would like to create a digital twin. We add these layers into QGIS using the Add Vector Layer tool. In the attribute table of the layers, and especially first layers, you can see the height information for all buildings in the study area. For example, if open the attribute table, the B3H max and B3H 70P fields represents building heights. We then selected one building from the study area and save it as a separate GeoPackage layer. Now we will create a simple LOT 1 digital twin for this building, single building. LOT 1 models are generated by extruding building footprints using height information. To visualize the building of 3D, we first open view, a new 3D map view, and next we right click on the building layer, open properties, and navigate to the 3D view tab. Here we can define an extraction height to create the LOT 1 model. In this example, we enter a fixed a height of 10 meters, but the B3H max attribute can also be assigned directly. Once the extraction settings are applied, the building footprint is extruded in 3D map view and generated the LOT 1 model. At this level of detail, as you can see, roof structures are not modeled, and the building is represented as a simple block. This approach can apply not only a single building, but also automatically to thousands of buildings at the city scale, making it a powerful starting point for digital twin applications. And then throughout these webinar, we explored how raw geospatial data can be transformed into intelligence geo AI workflows that support real world decision making. We are seeing a clear shift in the GIS industries from traditional mapping to decision intelligence systems. With Geo AI, we can now combine data, automation, and spatial reasoning a single workflow, and extend these into digital twins where the real world is continuously mirrored and analyzed actually in a digital environment. Even with tools like QGIS, simple load bound digital twins can be created quickly using buildings, footprints, and high data, which is often enough for urban planning and visualizing. In the next section, Anthony will take this further by showing how.
So, my name is Anthony Ezema. I'm an FME expert. My topic for this presentation is using FME to instantly extrude 2D footprint output. So I will be able to create the load 2 and make the necessary conversion using the FME. So this is the FME workflow that we developed for load 3 generator. So especially this, why we call it load 3 generator workflow, because it prepares the load 2, which will be generated on the web application that is being developed by Evotech Geospatial Consult. So I'll do a walkthrough on how this FME workflow works. For some of us that don't know the full meaning of FME, is Feature Manipulation Engine, is an ETL tool that helps in extracting, transforming, and loading data. So the first part I have to do is by adding a reader. So from the load 1 that was created by Gamza using the QGIS, I add it here as a reader on the workflow. Then I also add the extruder transformer, which enables me to maintain the actual height that was given to this particular load 1 data. Then here I also have the writer, where I'll be writing the output of the particular load 1 data. By the time I process it through the extruder, it maintains the load 2 data, and it's also being converted to objects. So if you look at here, what we are having here is object file name for this particular Netherlands load 1 data that was generated with the QGIS. So here is our inspector. So let me just quickly run through this and let me show you. Okay, just a moment. Okay, so from here, let me run the workflow to the inspector so that we'll see the process of how the workflow will be able to generate the load 2 data. So let's wait for the workflow to finish running. So here we can see the output. So this is the output of our load 2, which is in a load 2 solid platform that was generated using the QGIS. So here is already in object format that will be utilized in our Evotech load 3 Twin 3D synthesizer web application. So this is the output that we need to utilize in that web application. Thank you so much. So my colleague Paul Ugu will continue from here.
My name is Paul Ugu. I'm a Python developer with an interest in AI. So in this presentation, I'm going to show you how you can transform the load 2 object into load 3. We can, I'm exploring the AI angle here, how we can use AI to help in this. So we have this web app which we built for this particular case. We can, of course, we can use Blender. We can use Blender to add the architectural features and make it a load 3 objects. But in this case, we decided to, for convenience, we decided to do a simple web app just to demonstrate this. So here I will import the load 2 image, load 2 objects. So I imported it. You can see I've given it, we have some features, architectural features. So we can change the roof, we can change it to any kind of roof, maybe parapets or door. We can use a double glass or even a arch entry. Or I can go to parapets. So these are just a basic. You can just use all these. You can just apply all these basic parameters to it in order to make the image. For this our twin. For this our digital twin purpose, we can apply these features, and we can go further than that to use AI in order to reconstruct it in a better, realistic way. So here, I can connect to AI and, for instance, okay, before that, let me also include the image. So we have this image. We can, you see, we can pick the palettes, the color palette from this image and apply it to this, our objects. You can make it look like a building. So the next, we can describe what you want. Maybe tell it to just a moment. Just type, give it a little description. Let's see what to come up with. So you can see, you can make it, we can transform it, we can make it as much as possible. We can make this, we can apply all these features and make it look as much as we want. Maybe this, especially with the help of AI. So next I will export this. Objects so that. So of course, when you are exporting, you set the location, the longitude and latitude, so that my colleague will use it in the next presentation.
Thank you, Mr. Paul, and thanks to everyone currently viewing and following closely. So I'll be taking up from where my colleague stopped, and there is the Cesium Ion web app. This is a platform that we are going to be feeding with the inputs that like the output that my last presenter, which is Paul, made available. So we'll be bringing it into this place, which is the Cesium Ion asset library. So from here, we have the option to add that data. And because of the long processing time and the limited time we have to get this done, I will be working with more like a demo for what has already been pre-processed. So from here, we have an history of content that have been processed before now. Here is one which, when we're able to add it through this platform, it comes and it's added on this table, which is the which gives us the opportunity to access the unique ID and also the name. So with it, we're able to have a general overview of what is being imported, and you have the option to see it on a plane or with a mock-up background representation. So at the moment, the user can choose to have the intention of working or getting more details as regards this particular 3D structure. There's an opportunity for you to be able to get that done using this 3D tile location editor. And this can be gotten by clicking on adjust tile set location, which automatically brings you to this page. And when you are on this page, you have the opportunity to manipulate your 3D model the way you want, because this is a Google Earth interface. So there's an overlay of a 3D structure on this Google Earth interface. Here we have access to the longitude and latitude information, and also adjusting the height, the position, and the altitude. So many users might not be comfortable with this and want to be able to get details as regards having this represented on an OpenStreetMap. So the person can also go ahead making use of the Sensium Sandcastle. Yeah, this gives you an opportunity to work with the code base, which you'll be making use of two vital keys. Number one is the default access token that is provided by the Sensium Ion, which creates you the opportunity to interact with the OpenStreetMap using the default token ID, which can be extracted from this access token page of the Sensium Ion, just to get it out and coming back to the sandbox, imputing it into this code base, which is in line 4. And the other thing you need to work with is the asset ID, which is the already positioned 3D model, which could be gotten from here. But that ID is uniquely obtained from this added input that was gotten from the previous speaker, which is the asset input. That is what we'll be feeding this code base with. And then on doing that, we'll be able to click on run. That will present us with this general overview where the 3D model is overlaid on the OpenStreetMap. And with it, there is a better representation of it in relationship to the street naming and also other physical structures that are in the OpenStreetMap. So in a bid to finally extrude it out or extract it for a standalone and probably share it for other advanced usage, you then click on the standalone, which automatically brings it out to the final output, which is this particular overview where the link can be obtained and shared or used for other further usage that is required by either the user or the client in question here. Thank you so much for listening, and I will hand over to the next speaker that will continue from here. Thank you.
Okay, thank you so much, Mr. Raymond, for a wonderful presentation of the session deployment. Okay, so our viewers, this is the time for question. You can use the ask question tab on this meeting, Google Meet, by raising your hand. We can allow you to ask questions, or if you feel free, you can send the question on the chat. So this is the question and answer period. Thank you. Does anyone have question to ask? Thank you, Nadim. Thank you. Mustafa, thank you so much for your comments. I can see the comments on the chat session.
Sandy, I have a question.
Okay,
Will we share the webinar video?
Yes, the webinar video will be shared with all the attendees through the email, and you will also have access to all our platforms like our website and also the LinkedIn. Please, if you are here and you have not followed us on LinkedIn, please, you can do as well to follow us on LinkedIn, so that through there you'll be seeing major updates will be dropping. We are also on X and Instagram and also on Facebook. But on LinkedIn and YouTube and our website, you can get more of our updates. I just want to share that in a no distance time, the Evotech Load 3 Twin 3D synthesizer web AI application will be live, and it will be a good thing that everyone that participated in this webinar, you will get the notification when it is live, so that everyone can partake in making use of this web app, because we all know that the digital twin is a thing that is really helping us in various sectors, that for us to be able to achieve a lot of processes with this particular web app. Thank you, everyone. My colleague, does anyone have any word to say to our viewers before we close?
Okay, thank you, viewers, for your time, and we look forward to seeing you present for other advanced webinar and other functionalities that will be made available. So this is just the phase one. Others will follow thereafter, so we should keep our fingers crossed as we expect more technological innovative ideas that we'll be able to implement in helping to actualize our daily activities. Thank you so much, everyone.
Yes.
Thank you. Yeah, thank you. Yeah, continue.
No, don't forget follow us. I said only. Thank you for attention for everyone. Your participation is valued. Thank you so much.
Yeah. Thank you to all the attendees. We are grateful for making up your time to be in this presentation. And just like the other speaker said, more things like more presentation we follow, and this is like the first phase. Our team cuts across GIS software developers, those in AI. So we continue to be making a more innovative solution, and I will be sharing it in future. Thank you.
Okay, thank you, everyone. See you in our next webinar. We'll update each and every one of you. If you have another upcoming webinar, we're going to send you a notification.